right, let's talk about Unit 10 on our semester exam. So Unit 10 was square root functions. There is a calculator portion and a non-calculator portion of this unit on the review, so make sure that you're watching the directions. Here, for simplifying square roots, you're allowed to use your calculator if you would like. We'll start with 1/4 square root of 24. Now, the 1/4 is a coefficient, so we're just going to leave that out in front for now. We need to break down the square root of 24. To do this, I like to find the biggest perfect square that goes into 24, which is 4. And 4 times 6 is 24. So that radical 24 breaks down as square root of 4 times square root of 6. Now when I simplify this, I still have that coefficient 1/4. Radical 4 breaks down to be 2, and radical 6 doesn't change. So now all you have to do is multiply the 1/4 into 2. 1/4 times 2 is 1/2, then the radical 6. You could also write that as radical 6 over 2 if you wanted, same thing. Number 2, when I have a negative under the radical, that means you're going to have an I in your answer because that's that's technically the square root of -1 times the square root of 144. Now the square root of -1 is I, and the square root of 144, that's a perfect square, is 12. So the answer here is simply 12I. For number 3, radical 13 over 7. Well, remember, you can break up a square root as radical 13 divided by radical 7. You can break that up over top of the fraction. Neither one of those square roots simplifies, so what we're going to do is we're going to rationalize the denominator as the directions say to do. To rationalize, you have to remove the radical from the denominator. So you're going to multiply the numerator and denominator by radical 7. Radical 7 over radical 7 is equivalent to 1, so you're not changing the value here. You pull out your calculator, note that 13 times 7 is 91, so that's under the radical. That doesn't simplify, so it's going to stay radical 91, and radical 7 times radical 7 is just 7. That's the square root of 49, and the square root of 49 is 7. And that's as simplified as you can get. Now the next three get a little bit more complicated. Number 4, I have a lot going on here. I have a square root, a negative, a number, and a variable with an exponent. Let's break up the square root over each part. We'll start with the square root of -1. That's for the negative. I'm going to write in different colors. Square root of 180. We'll break down that square root. And then we'll have a square root of x to the 16th. Now, the square root of -1 is I. The square root of 180, well, I can break that down. I'm going to use my calculator and find that the biggest perfect square that goes into 180 is 36, and it's 36 times 5. So I'm going to break that down there. Now, what I want you to remember is that we learned later on in the year that the square root is equivalent to raising something to the 1/2 power. So I'm just going to rewrite it like that for now. X to the 16th to the 1/2. And then when we simplify here, we're going to keep the I. All right, so I'm going to bring this down. I'm going to reorder it. Have the I. The square root of 36 is 6, so I'm going to put the 6 in front of the I because that's the convention. The radical 5 doesn't change. Oops, actually, I'm going to move the radical 5 over just a little bit. All right, so I still have my I, my 6, my radical 5. And then x to the 16th to the 1/2, that's equivalent to x to the 8th. So that's how I'm going to write the answer. You can write those terms in any order that you want. But 6i x to the 8th radical 5 is the simplified solution. It's a little complicated, but you have the skills and the knowledge to answer that question. Number 5 and 6, you're rationalizing the denominator using the conjugates. Now the conjugate of 6 minus radical 5 is 6 plus radical 5. So you're going to multiply the numerator and denominator by 6 plus radical 5. Carefully, you're going to make sure that you are multiplying here. So you're distributing the 2, not just to the 6, but also to the radical 5. Your new numerator becomes 12 plus 2 radical 5. Now in the denominator, you're technically going to FOIL here. I'll write it out underneath, and then I'll show you the shortcut. 6 times 6 is 36. 6 times radical 5 is plus 6 radical 5 minus 6 radical 5. And then here I have negative radical 5 times radical 5, which is square root of 25, or minus 5. Now, the middle terms are always going to cancel out there. So really what you have is 36. Remember, it's 6 times 6. And radical 5 times radical 5 is 5. And you always have a subtraction there because you're taking one negative times a positive. Now, if we simplify this, 12 plus 2 radical 5 doesn't simplify, and 36 minus 5 is 31. That would be your most simplified answer because none of those terms can simplify anymore. Same idea in number 6 here. We're going to multiply by the conjugate, 2 minus radical 3. Now I'm going to start by distributing the 1 to both terms. 1 times 2 is 2 minus radical 3. Neither of those change. Now if I'm going to FOIL the denominator here, remember the middle terms of the radicals are going to cancel out. So I really only have to worry about the 2 times 2, which is 4. Now minus, because I have a positive times a negative, radical 3 times radical 3 is 3. So what I have here is 2 minus radical 3 over 1. And you can simplify that to just be 2 minus radical 3. They're equivalent. All right, for the next two, you're going to need your calculator. So pull that out. I'm going to pull out my calculator as well. All right, so we're going to be solving square root equations. I have you pull up your calculator because we're going to use that to check and see if our answers, if any of them are extraneous. So to solve this, I guess you're not Algebra 1, you don't need that. To solve this equation, you need to make sure that you are isolating the square root. So you want to isolate the square root of x plus 5, which means first I have to move the 7 and I have to move the 2. So I'm going to start by subtracting 7 from both sides. When I do that, I'll have 2 times the square root of x plus 5 equals 6. All right, I still need to move that 2. I still need to isolate the square root here. So I'm going to divide both sides by 2 and get the square root of x plus 5 equals 3. Now, in order to get the x by itself, I need to move the square root, which I'm going to do by using its inverse by squaring. And I'll get x plus 5 equals 9. And then I subtract 5. Now, I do get a solution of x equals 4 here, but I want to decide if that is actually my solution or if it's extraneous. So remember, you have to check your work, and this is where your calculator is going to come in. You can do it by hand, but I think the calculator is faster. You're going to substitute back in the 4 into the original expression for x. All right, you're going to have 2, and then you're going to put the 4 in for x. See if the answer you get is equal to 13. Okay, so here's what I'll do. I'll take 2 square root. Now, instead of x, I'm putting my answer 4 plus 5. Then outside the radical was a plus 7. When I hit enter, I get 13, which is what our original solution was. So I know that 4 is actually a solution and not extraneous. All right, number 8 here, a little bit more work. I have already my square root isolated on the left-hand side. So I'm going to start by squaring both sides so that I can get rid of the square root. So I'll have 3x plus 16 equals, now when I have a quantity x plus 2 squared, I'm going to rewrite it like this, x plus 2 times x plus 2. I'm going to end up having to factor here. I'm going to start by distributing, FOILing on the right-hand side here. So I'll keep the 3x plus 16 on the left equals, and that's going to end up being x squared plus 4x plus 4. All right, now, in order to solve and factor, I'm going to move this 3x and the 16 to the other side so that I'm set equal to 0, and I can solve using the zero product law. Just like Unit 7, the first video, the first unit on this review, in order to factor and solve a quadratic like this, you're going to have to set it equal to 0. All right, so now we factor. Two numbers that multiply to negative 12 and add to 1 are 4 and negative 3. So we'll have x plus 4, x minus 3. And then when you set each factor equal to 0, you get one solution at negative 4 and one solution at positive 3. Now the situation here, these could both work. One could work or neither of them could work. So you have to use your calculator to check. So I'm going to start with the negative 4. I'm going to put the negative 4 in for x on the left-hand side of the equation. So I'll take the square root of 3 times negative 4 plus 16. When I hit enter there, I get 2. Now if I check the other side of the equation, I would have negative 4 plus 2, which is negative 2. Those are not equal in value, which means that negative 4 is not a solution. That's extraneous. So let's check x equals 3. Let's see if that's a solution. So we'll do the same thing. Let's start with my square root. 3 times 3 plus 16. I get 5. Now the other side of the equation was going to be 3 plus 2, which is also 5. So that means that 3 is a solution. So we have one solution here and one extraneous solution. Remember, the other way that you could solve these is by graphing both sides of the equal sign. So you could graph the square root of 3x plus 16. And then the next line down, you could graph x plus 2. And when you graph them, you see that they only intersect at one place. And if you trace where the graphs intersect, you'll see that they intersected x equals 3, which was our solution. All right, you can do the same thing for the first one as well. You could go back. I know I'm skipping around here. The first equation was 2 square root of x plus 5 plus 7. You wanted to know if that was set equal to 13. So if I change my y max here and graph both of them, you again see that they intersect in one place. I'm going to find that for you. And the intersection was at 4, which was the solution that we found for the first one. So if you have the option to use your calculator and you don't know if you're doing it right or you're not sure how to solve, graph the two sides of the equation, set them equal, and find where they intersect. All right, a couple more problems here. State the domain and range. Now, domain and range, this is going to be a little bit more challenging for the second one, number 10. You are allowed to use your calculator for the range. I would suggest you try the domain without a calculator. But if you're not sure, grab your calculator and graph it. This is a calculator allowed question. All right, the thing to remember, when you're underneath a square root, you cannot typically have a negative number. Those are imaginary. So we want this radicand, the stuff that's under the square root, to be 0 or bigger. So greater than or equal to 0. So we're going to solve this little equation here. And I'll get 6x is greater than or equal to 5. I'm going to divide by 6. I get x is greater than or equal to 5 over 6. That's actually your domain. You can write it two different ways. You can write set notation here, x. The domain is the x's such that all the x's are greater than or equal to 5, 6. Or you can write that in interval notation. So 5, 6, if they're all bigger than 5, 6, you would go from 5, 6 up to infinity. Everything greater. If you have to draw a picture, 5, 6 is here, and we're greater. We're going out to the right towards infinity. Now the range, this is where I would use my graph. Okay, so I'm going to clear both of these. And my equation was the square root of 6x minus 5. When I graph it, first of all, you could trace the 0 here and see that it's 5, 6. But it looks like my range goes from the x-axis of 0 and it goes up forever. So my range there will be all the y's such that y is greater than or equal to 0. Or you can write the same interval, 0 to infinity. Right? Either option is fine. Now number 10 gets a little bit more complicated. So you can use your calculator for both, but I want you to try the domain without. All right. So number 10 here, to find the domain, you first take the radicand and set it greater than or equal to 0. Now, we learned this trick in Unit 13, the rational functions unit. If I have this difference of squares kind of in a different order, I'm going to factor out a negative here, so I can rewrite this as x squared minus 4, greater than or equal to 0. Right? Because when I do that, look, I can factor here, x minus 2, x plus 2, greater than or equal to 0. That kind of looks like a quadratic inequality that we had in Unit 9. And these quadratic inequalities, if I know the roots, and here the roots at positive 2 and negative 2, My graph is negative, so it's upside down. My quadratic looks like this. Now I know this is a complicated domain problem. I want you to make sure you understand it, and then I'll show you how to use your calculator. We are greater than or equal to 0, so we would have closed dots here. And greater than means above the axis. There's one portion of my graph that's above the axis. So that portion, that inequality right there from -2 to 2, that's the domain, right? I want the x's from -2 to 2. Or in interval notation, it would look like this. Now, I know I went through that kind of quickly, but let's look at the graph, and you'll see why that makes sense. When I graph this function, whoops, I have 4 minus x squared. When I graph it, look, it's a little semicircle, and it looks like my domain on the left is from -2 to +2. Now let's talk about range. It looks like the lowest y value is 0, and it goes up to the y value of 2 right there. So my range here would be from 0 to 2, or the interval notation, 0 to 2. Right, that's a more challenging one. Make sure you understand domain. Just in general, that square root functions have to be greater than or equal to 0, the value under the radical. Last question here is no calculator. All right, all we're going to do is state the transformations that have occurred to the graph and then find the equation. So the transformations here, it looks like, remember your parent function? I don't have a lot of room here, but it goes out like this. That graph looks like it was reflected over the y-axis. And one thing we know about reflecting over the y-axis is that the negative is underneath the radical. So I can eliminate options A and C. Those are reflected over the x-axis. The other thing is my graph was shifted up 2. And the up 2 is a +2 outside of the radical. This looks like option C. All right, if you have questions on this unit, ask your teacher for help, check the key on Canvas, or go back and look through your old quizzes and tests.